Hello guys, welcome back to the Python crash course. In this video, we'll explore bitwise operators, which allows you to manipulate data at the bit level. So these operators are incredibly useful in low-level programming, optimization, and working with binary data. So don't worry if this sounds a bit complex, we'll break down it down step by step with clear examples to help you understand exactly how bitwise operators works. So let's dive in. So these are the six bitwise operators. What do we have? Bitwise AND, bitwise OR, bitwise XOR, bitwise left shift, bitwise right shift, as well as bitwise negation. So let's see one by one. So normally when I say bitwise, so binary comes into picture. So when I say binary, zeros and ones comes into picture. Let's take some random decimal number 13 and let's convert this number into binary. If you want to convert any number into some respective base, we are supposed to divide that respective number with the base what we are trying to do. As in binary, base 2 is the value. Now let's break down 13 into binary by dividing with 2. So 2 6 are 12, so we get the remainder to 1. So next two threes are 6, reminder to 0. Next two ones are 2, reminder is 1. So now we got the value 1011 from top. So let's consider from bottom 1101. So now the value of 13 is 1101 in binary base. So if you want to cross validate, is 1101 the correct value of 13 in binary? Let's validate. So as I told, in binary the base is considered as 2. So last we have 4 bits 1101. Let's take all those 2 power 3, 2 power 2, 2 power 1, 2 power 0. So let's take all those 4 bits the same. So now 1 into 2 power 3 would be 8. 1 into 2 power 4, I mean 2 power 2 would be 4. 0 into something would be 0. And 1 into 2 power 0 would be 1. So now 8 plus 4 plus 0 plus 1, the answer would be 13. So this is how we convert the given decimal value 13 into binary and cross validating the same binary value into decimal by this format. So let's now dive into all the bitwise operators one by one. So let's first look at bitwise AND. So now let's take two bits A, B, and let's try to do A bitwise AND B. As we have seen in our previous video, when it comes to logical AND, if either of the value is false, the entire condition would be false in logical AND. The same applies to bitwise AND. But in bitwise AND, here we work only on bits, which are zeros as well as ones. Here 0 bit is considered as a false value. If you find any of the 1 bit to 0, the output would be 0. Let's take two examples. 0 0, the output would be 0. So 0 1, as we found 1 0, the output is still 0. So 1 0, we have 1 0 at least, so output is 0. If all the bits are ones, the output would be 1. So this is with respect to the case of bitwise AND. Now let's see the case of bitwise OR. So let's consider the same thing, A as well as B. So now instead A and B, now let's try to do A or B. So as we discussed the same thing in the previous, when it comes to logical AND, if either of one condition is satisfied, the output would be true. Here also the same thing. If either of one bit is 1, the output would be 1. So now if you observe the first case, both the bits are zeros, then of course the output would be 0. So one second, yeah. So now here 0, 1. So among these two, one bit is 1. So the output would be 1. So 1, 0. So the output would be 1 again. So at least we have 1, 1 here also. The output would be still the same 1. So this is with respect to logical or, sorry, bitwise or. Now let's see the last bitwise operator, which is bitwise XOR. So we'll consider the same inputs A and B. So the output would be A XOR B. When it comes to XOR, if both the bits are same, the output would be 0. If any of the bit is different, the output would be 1. So if you observe this one, 0 and 0, both bits are same. So XOR of these two would be 0. Now let's see for the next one, 0 1. Both the bits are different here, so the output would be 1. So 1, 0. Both the bits are different here. The output would be 1. So 1, 1. Both the bits are same here. So the output would be 0. So this is with respect to XOR. Let's take 1, 2 examples and try to find how do we get it. So let's try to take two numbers, 5. So binary value of 5 is 101, 6 is 110. So let's try to do 5 bitwise and 6. So if you want to do 5 bitwise and 6, let's try to do the same thing. 101 considered, 110 considered. So now if you see from the leftmost bit, both the bits are ones. So this is 1 and this is also 1. So the output would be 1. So here 0 and 1. One bit is 0. So the output would be 0. Here also one bit is 0. The output would be 0. So 100 is the value what we got. But 100 value the same in decimal base is 4. So 5 bitwise and 6, the answer would be 4. So let's also try to do the same for 5 or 6. So let's see what do we get. 5 is the same 101. For 6, we go for 110. If either of one bit is 1, the output would be 1. So the output will be 1, 0, 1, you have one bit 1, 1, 0, you have one bit 1. So the answer would be 7. So this is with respect to 5 or 6. So now let's go for 5 XOR 6 and let's try to find what is the output for that. Same 101 considering the same. 110 is also the same. Let's try to do the XOR. Now you see the leftmost two bits, 1 as well as 1. As both the bits are same, the output would be 0. 0, 1. Both the bits are different, output is 1. 1 XOR 0. Both the bits are different, the output is 1. So now we get the output to be the value 3. So like 5 bitwise and 6, the answer is 4. 5 or 6, the answer is 7. 5 XOR 6, the answer is 3. So like I'm adding one more point over here. So if two bits are same, the output would be 0 when it comes to XOR. If two bits are different, the output would be 1. If you want to take one more example, let's say we are working on three individual numbers. So let's take three individual numbers like 4, 5, 6. So 4 value is 100, 5 value is 101, 6 value is 110. So if you try to perform XOR among these three, let's see what do we get. So as there are three values, now what do we are supposed to do? First, evaluate the first two bits, the resultant answer, then you evaluate with the last bit. Now 1 XOR 1, the answer is 0. 0 XOR 1, now the answer would be 1. So this is for the leftmost. So here 0 XOR 0, as both the bits are same, the answer would be 0. So that 0 XOR 1, the answer would be 1. So 0 XOR 1, the answer would be 1. 1 XOR 0, the answer would be 1. So you get the value to 7. So these are three individual bitwise operators, bitwise AND or XOR. Let's try to see the same result in our IDLE shell. So let's go to Python IDLE. So let's try to take the same things. So num1 to 5, num2 to 6. So let's try to perform bitwise. So num1 bitwise and num2. So the answer is 4. Similarly, num1 bitwise or num2, the answer is 7. Num1 XOR num2, the answer is 3. So let's also try to perform 4 XOR 5 XOR 6. So the answer is 7. So let me try to add 2 more points. So if we do 5 XOR 5, so we would get the answer to 0 because in 5 the bits are 101, in the other 5 also the bits are 101. If both are having the same bits, the answer would be 0. So if I do 0 XOR anything, if I do 0 XOR 8, the answer would be 8. So if I do 8 XOR 8, the answer is still 0. So if I try to take the combination of 5 as well as 8, 8 XOR 5 XOR 8. So instead use this in a manual way, but we already know the result. 8 XOR 8 is 0. So now you can directly do 0 XOR 5. So you get the answer to be 5. So remember this point. We'll be using this scenario in our upcoming series. So that's all for these bitwise operators and or as well as XOR. So remaining bitwise operators will be covering in the next video. Thanks for watching. See you guys in the next one.